Hi, welcome to the webinar today on Automation Studio E7. We will present a quick overview of the PLC module of Automation Studio, the one more targeted to Allen Bradley. So we will show you the basic that we have, the AB-500 and AB-5000. We do support both with addresses or tag name. This will last about 45 minutes, and then after that we'll take 15 minutes to actually build the third part of the multi-technology project that we started 2 weeks ago. So we've started with the pneumatic part the first week. Last week we've done the electrical part where we actually built the motor control and we inserted the graphic illustrated view, let's say, of the Compact Logic PLC. And today we will be focusing on building the control that will automate the entire system. So my name is Christian Proto. I'll be the one presenting the webinar today. There's too many people connected, therefore we won't be able to take your questions live during the presentation. But we do have a question option in the GoToMeeting interface where you can write down your question and we'll try to answer them as we go. Or at the end, we will actually be open for question, and at that time we will give you access to actually the mic so you can ask your question live during the presentation. And for the question part at the end, there's no time delay. Okay, so we'll be available to answer any questions that you may have. So thank you again for being here this morning, and let's start the presentation on the quick overview PLC, ladder logic, basic, AB500 and AB5000. Okay, so this is the interface of Automation Studio E7.1. So as you can see, the software includes multiple libraries. We have hydraulic, proportional hydraulic, pneumatic, drive and transmission, electrical control for relay logic circuits, logic gates, PLC, Allen Bradley, IEC, Siemens, Mitsubishi as well, electrotechnical for AC, DC motor control, one line diagram, mathematical blocks, and some control panel unit components. Now that we're talking about the Allen Bradley PLC, let me just build a little pneumatic cylinder because I want to actually be able to control something. Okay, so I'm just going to come here and drag and drop very quickly a cylinder, a 5-2 directional valve. I'm going to then put the pressure source here, the exhaust, hit the control key, put another exhaust here. This is the question mark because my solenoid here needs to be connected to an electrical circuit. Connect this ear and ear. So basically this is a very quick circuit that we actually went through this part in the first video a couple weeks ago. So now if I just want to test the simulation, I can go here and just test that. Okay, everything works fine. So now I can actually build a control part for this. So if I go into the, like I said, we have Allen Bradley, we have IEC, Siemens, Mitsubishi. Today we'll focus more on the Allen Bradley. We have three different types. We have this one here, which is the old-fashioned one that we've been using for the last 10 years. Okay, and then with its limitation, okay, I will explain a bit during the presentation. Then we have the Allen Bradley 500 and a 5000. Okay, so basically if we start by using the basic one that we've been using for many years, we can actually put this ladder diagram directly on another sheet where it has a pneumatic, hydraulic, or a virtual system. Okay, so basically, let's say I'm going to go into my electrical control. I'm going to take a PLC card like that, the input, and the PLC for the output like that. Then I'm going to go into Allen Bradley, the basic one here, and I'm going to put the rung in the middle. Okay, it's a bit too big, but I can just shrink it like that so it fits into between my card. Okay, now let's put the electrical part to control this circuit. So basically I'm going to go back to my electrical control, put like a 24 volt here, put a push button. I can call that the start. And then I'm going to put the common at the bottom here, 0 volt. That's it. So if I start the simulation, you see that my start is actually energizing my input 0 on my card. Okay, so now what I'm going to do, I need my output now to actually trigger my solenoid. So I'm going to put 24 here. Okay, the output card, I know some people put the 24 at the bottom, at the common, and 0 on top. It's really up to you. In Automation Studio, we don't make a difference at this point, so I can actually connect this like that. Just lift it a bit. I'm going to put a solenoid here, and I'll call this A+. I'm going to connect that. And now I need to associate the solenoid on the valve to the A+ over here. So click twice on it. Filter for A, and you see A+ is here. Click twice. And now this is linked with my output solenoid. But there's no logic in the middle, so I need to put the logic that would be in the PLC to make this work. So let's go first by going to the Allen Bradley. I'm going to take an open contact here, and I'm going to link this open contact to my in 0. So I click twice on it. Then I'm going to filter for I for in. You see all my inputs are here. Click twice on in 0. And I can actually see now it's linked to the card and in 0. Then I'm going to go here. And let's say it's going to be like an internal relay. Okay, let's see if I call it, let's say B203. I can put here any names that I want. Okay, let's say 0.1. I don't know exactly how the structure is made, but you can put the text that you want here. So let's connect this here to my run. And now I need to latch my in 0, my start. So I'm just going to put a normally open contact here too. And I want to link that to B203. So click twice on it. Filter for B. And here's my B203. Like that. Now you see they're linked the same. I can just latch my input 0. And then I want to actually trigger the solenoid. So I can hit the control key, copy this down here, connect it like that. And actually now I'm going to be energizing here out 0. So I just click twice on it, filter for O, and you see out 0 is over here. Click twice. And now if I connect it like that, if I launch the simulation, push once, cylinder extend, and the signal is maintained. So basically what I want to do, I want to put a proximity sensor here to make it retract. So I'm going to come here. Let's just move that in the center here. It's going to look better. Oops, sorry. Let's just select this like that and move it here in the middle. And now I need to put a proximity sensor on that cylinder to actually tell me that it reached the end of a stroke. So I'm going to go here into Pneumatic, take a proximity sensor. I'll position it here, and I'm going to call this A1. Now on my input card, I'm going to take also contact of a limit switch, proximity sensor like that. I'll put it on in2, and I need to link that to A1 now. So if I click twice on it, and then filter for A, and here's A1. Click twice. And now this will actually be my sensor when the cylinder hit the end of stroke. And when it reached the end, I simply want to make it retract. So since there's a spring, all I need to do is de-energize A+. Then I'm going to go into my Allen Bradley here, take a normally close. I'm going to put it right here, and I'm going to link that to my in2. Click twice. In2 is over here. Click twice, and now it is connected to my in2. So if I launch the simulation again, push once, goes to the end, and then it retracts. Like you saw in the previous video, if I want to slow this down a bit, I can go into the simulation, go slow motion or step by step. But what I prefer to do it's actually click twice on the pressure source here and reduce the orifice here, let's say 0.02, okay, like that. And so less flow is going to go through it, and it's going to move much smoother now. So if I launch simulation again, you'll see right away. If I push start, it extends, triggers A1, and retract. So this is the way we can build the PLC using the old basic Allen Bradley that we had in Automation Studio 6.4 and before that. Okay. Let's say I just want to add a timer. Just let's say when I trigger A1, I want the cylinder to wait 3 seconds. No, you know what? We'll do the timer part in the real AB-500 and 5000. Okay, so this is we can build a very basic logic in Automation Studio very quickly on the same schematic of other technologies. Okay, so now what we're going to do is we're going to do the same thing, but this time using the new AB-500 library. Okay, in this library, you see we've named all the components the same as they are into the software itself. And what I need to do now is I'm going to have to erase this part in the middle, delete it, because I'm going to have to do the control with using the AB-500. And you'll see this one requires a different document. Okay, so for example, you see if I try to bring a contact on this type of document, you see there's an error message because you need to have here a new document for ladder diagram. And now you can choose AB-500, 5000, LS, or Mitsubishi. So let's go for a 500. So this opens up. Let's do something first. Okay, so let me just go back here. This is our small circuit, so we're going to save that. Okay, so at least we will take it from there. So let's say this is going to be project PLC. Okay, now I'm going to go into my 500 ladder. You see it's a different sheet, but I can still view both one beside the other. You know, if I go view here and I go vertical tile, I'm going to have both one beside like that. So on this window, now you see I can drag these components, but I cannot drag any other component out. You see if I go hydraulic, I can't put anything like this on it. It's specially made for the AB-500. Okay, so before we start, we have to establish which variable we need. Okay, so it's like if we need to, like the data table, let's say we need to establish in here. So you see we have a new toolbar, it's called ladder. Once I'm here, I have here the PLC configurator. If I click here, so this is the 500. So you see now I have no variable. Now I'm in the routine, sorry, the registers are here. So these are all the ones that exist by default, you know, like the first pass and like you'll find on real PLCs. Then we can have the inputs, outputs, which there's none right now because we need to add the one that we want to use. So when I click on plus, you see that this gives me all the variables that are available. You see if I search for my inputs, you see these are the inputs that are my card here. So I know I just need input 0 and input 2. So I can simply click twice on in 0 and on input 2. I don't need to bring in the other value if I don't want them to, I don't want to see them in here. But I can also if I want to. Okay, it's up to you. But I'm just going to bring the one that I need. And on my, those are input and my output, let's filter by O this time. I just need my output 0. Okay, so the software will, and then you close that. Now you see I have my 3 inputs that I need. Here you can put if it's an output or an input. sometime you just need to double check, okay? We will kind of like pre-read the alias and the information about it to know if it's an input and output, but sometime double check to make sure. I've made that mistake before where I thought it was already set and it wasn't set properly, okay? So just make sure here. And the in0 here, you can establish the addresses, okay? So the address for an input, okay, it's I column 0/1. Oh, 0.0/1. Then I can copy this here, and this is going to be 2. On my output, it's the same, so it's O column 0.0/1 /0, this one, you see? 0. And here I put 1, but it should have been 0 if I wanted to match what I have on my drawing. 0 like this. I could have put also an alias, a description, or something else, but I can just leave it like that. So now if I close this, I have pre-set 3 inputs or outputs for my PLC to have access to. So let's just bring the power rail out. Let me just zoom in a bit. Let's just zoom all component like this. And now when I push start, I want to have my in0. So I'm going to take an XIC. And you see here, I can directly type in the address. Okay, I can open here at the bottom and see my inputs that are here, or I can just type it. And here we have also an help that tells you how to write the different addresses for an input, output, timers, and things like that. Okay, so I can be simplified. So let's just put my in0 here, let's say. You see it's already there. And then if I close, you see so this is linked to my in0. Then I'm going to energize an internal relay. So it's going to be a B203. So B3 column 0/something. So I can say B3 column 0. So here, B3 column 0/1. And I can name it like that, like internal. Okay, it's really up to you to add the alias or not. And now I have my B301. I'm going to put normally an XIC again here, which I will link to my B3 here, internal. Click twice. I can actually now connect these together. So it's a bit the same as before, but this offers a lot more. You need to use the addresses here. You can't do anything else. While with the old PLC we had in Automation Studio, you can pretty much do whatever you wanted back then. Okay, but I still have the same function. If I want to copy this down here, I can just hit the Control key and do it like that. I'm going to energize here my out 0. Connect this like that. So basically my logic is done, but now I need to read the in2 to stop my B3. So normally close here, and this will be my input 2. So now if I launch the simulation, if I hit start, you see it works exactly the same way as we did before, but now it is based on the AB-500. Okay, so same thing now. Let's say I want to put a timer now. Okay, so when I trip the I1, I want to wait 3 seconds before it retracts. So basically I'm going to delete this one here. I'm going to take an XIC over here. This will be linked to my input 2. Because when I trip A1, input 2, I'm going to put a timer. Okay, you can expand here if you want and go for a timer, counter, compare, computer, move, array, file shift, sequencers. So these are all the functions that you want. Let's put a timer over here. You see, it looks a lot different now than what we have in Automation Studio before. We really need to put in the right addresses now. So a timer, it's a T4 column 0, 255. So let's name it T4 column 1. Alias, I'll put cylinder delay, for example. Then the time base, and I want to put, let's say, for, okay, this is 1 second. If I approve, now the preset is going to be 3 seconds. So when I close, so now you see I have my T4, 3 seconds. And now I need to go actually use the done bit of my timer to reset this here. So I'm going to come here at the bottom. You see my timer done bit is over here. Click twice. And there's my done bit of T41. So if I launch simulation again, start, count to 3, then retract. So this is a very small circuit, but I mean, you are people that are teaching PLC, so I mean, you can do very large project here. This is just to show you, and you know, when I'm in simulation mode like that, I can just go again and view vertical tile just to make them bigger like that if you want. It's not a problem. It's just that when I stop simulation, the library kinds of like push everything aside. Okay, so let's do vertical tile again. And now that we've done this model, we're going to do the exact same thing, but using the 5000. Okay, so let me just reopen the circuit that we saved before with the project PLC. We've developed these two modules, by the way, because we've had a lot of limitations, I would say, with our old version. We could not write in the same variable, so we couldn't do a latch and unlatch. It was kind of like we need to use the two symbols that were combined together. It wasn't really like working with the real PLC, and this new models now are much more closer to the real thing. So let's come here and let's just erase this ladder diagram because I need to have the one for 5000. So ohm, document, ladder diagram, AB-5000 this time. Again, we're going to do a vertical tile. Same as before. So we go into the ladder, we go ladder here, and we need to go and actually add the inputs. So I'm going to choose here 5000. And I'm going to click plus to actually add the same thing. So let's add out 0. Let's go with the input, add input 0 and input 2. But you see here what the difference is that we actually have to put here a tag name. So I need my input 2, let's sort them by order. My input 0 is going to be called, let's say, start. Then I'm going to put my input 2, let's call it a sensor, or let's say cylinder extended. And on my output, it's going to be just sol 1 directly. Sol 1. And now I'm ready to write the same logic as we did before. So I'm going to go now into the 5000 and just do the exact same thing that we did. Let me just zoom all. Bring in XIC. I'm going to put it down here. So now I can go down at the bottom here, click twice on start, and here it is. Start. Then I'm going to come here. This is an internal relay because I don't need to call it anymore BO3. I can just say internal 1, let's say. or latch or whatever you want. And now I'm going to put my XIC down here to link it to latch. So here, latch 1, click twice. Connect this together. So it basically the same as we did before, but instead of having addresses, now we actually use tag names. So when it's latch, it's going to energize my out 0, which is actually sol 1 now. Sol 1 is here. And then if I link that together, let's put the timer right away, okay? We won't waste too much time here. So when my input 2 is triggered, so let's put that here. Input 2, it's my sol cylinder extend. When it's extended, I'm going to put a timer. So you see the timer works a bit differently in 5000. So here, I'm going to actually, let's name it delay cylinder. Preset time, now it's in milliseconds. I have to put like 3000 like that. So 3000, if I close that, now it's set. And now I'm going to put a done bit over here. So drop it here. And you see, if I go at the bottom, here's my timer. I can extend it and actually click twice on my done bit. Okay, you can expand that if you want, you know, and then if I close, that's my done bit of my delay cylinder. If I simulate again, it works the exact same way. So now you have the AB-500 with the addresses, and we can use the 5000, which is more geared towards tag names. Okay? So these are the two new libraries that we've done into Automation Studio. And we can also, just to continue the presentation, I'm going to show you some demonstration of what else can be done with this module. Okay? Keep in mind that this is just a very introduction to this PLC. If you want, we can schedule an online presentation with one of our specialists in that area that will be able to go through all the very detailed functions and then monitoring and accessing the sequencers and whatever you want. So that's not a problem. You just contact us and we will definitely schedule an online presentation with you and your colleagues to go in more depth into the PLC Allen Bradley. So let's just start a new project. I'm gonna save that. Let's say project save as, and project PLC 5000. Let's say. Because this is, I've been showing you like very basic, but I'm going to open a couple of more projects to show you what we can do. Okay, so let's just open here. So let's say we have something here, and let's say it's called AB A plus B plus with the 5000, sorry. So a bit exactly like we did now, but just a bigger circuit. Same thing, we had the input and output card, and if I simulate, it just works well according to how it is set up on the right. Okay. Okay, we have one here which is called a drilling factory. So same as we have like a virtual system, this one it has more input, more output. We have about 15 different systems like that, okay, which has a bunch of input, output, and then we have the program here on the right. So you see, if I zoom out a bit, let me zoom in. So you see we have very, this is a bigger circuit with move functions and things like that. So the software will support much larger project than just the one I was showing you at the beginning. Okay, so now if I simulate to show you, if I hit start, you can see the circuit in simulation, and that circuit is controlled with the actual PLC that we have over here. So it's interesting with the virtual system like that. It's that student can write their program, and as they write the program, they can actually see the circuit in action, and they can follow what's going on with the PLC on the other side. So as they build this, they can actually follow what's going on. We have all kinds of system: car wash, traffic light, elevator, pick and place, filling bottles. So a lot of different virtual systems to work with. From basic to a lot more complex is really up to you. So this is more geared towards the 5000, and I could have used the exact same thing but with the 500. So if I open here the same circuit but with the 500, it's a bit different. It was built by someone else, so it took a different approach. So you see what we did is we have all the addresses that are there, but we also put the description like an alias, and we decide to highlight it with a different color. Okay, all these things can be set up in your template. If you go to ladder here, okay, we click on ladder. This is for the, oh, I'm sorry, you see I was editing the LSS, the LSCS PLC. I need to use this one is AB-500. I need to come down here, then you see this is where I can set up my tag. So the background here, that's green, if I put it yellow and I approve, you'll see what happened. You see they all turn yellow. Okay, so you can change the way you want it to look for your students. It's up to you to decide. Okay, even the size of the length of these contacts. You know, if you're working on a big project and you need to put more contacts, you can click on it, and in the data here, you see the length is 3. If you put 1, you see how small it is. So you can put more beside each other. We've put it a bit wider by default because you see the comments is as the same space. So as soon as we put a bit of text, it was automatically going on the second line. So by putting it a bit bigger like that, we can support quite a bit of a description above it. Okay, that's why the default is that width. But if I start simulation on this one, same as before, I can follow the sequence on my PLC, and this is what is controlling the machine on the left. Okay, so this is what I wanted to show you for the PLC, our virtual systems. What we've come up with also recently is that we have new illustrated PLC. Okay, so let me just open a standard diagram and I'll show you what I mean. Oh, sorry, a new project. I'm just going to do a new project from scratch. So let's say here Imperial Unit. This is very interesting because I talked about that a bit into my past video on the electrical part, but it's important to do it again. You see how we've brought in some input card and output card from here on the schematic to connect to it, but in this version 7.1, if you click here on the orange book, you can open a PLC library, illustrated PLCs here. And we have some PLCs, like we have Siemens, different models, S7 1200, 200, Schneider, Omron, Koyo, this is the click. So for example, if you take out the PLC, you see this is the click PLC. So the students need to know how to energize the PLC. And here are my inputs and outputs that I can connect to my push button, my lights, my relay, and things like that. And if I do, let's say, a new document, a ladder diagram, let's say I want to program this with the 5000. Because it's not because we have the PLC on a graphic view that we have the same programming interface with the same functions and things like that. Okay, it's basically this was made to teach students how to wire up different type of PLC. But if we do the ladder diagram, we can control it anyways. If I go here, vertical tile, this is my click. If I come on my ladder, I go here and I go PLC configurator. This is where I'm going to be able to bring in some inputs. So if I click on the plus here to bring inputs, you see on the Koyo, on the click, it is the X and Y. So input are X, outputs are Y. So you can bring them in your interface as well, the one that you want. Now I'm going to bring them all just to show you. So you see now they're all available here. And you see they are all tagged as input, like I was telling you before. So I know my Y's are out, so I'm just going to come here and say this is an output. This is an output. And then I can just, after that, give it a tag name that I'll be able to use with my 5000. Okay, so this is how we can do a basic PLC, one more oriented toward AB-500, another one towards the AB-5000. Like I talked to you at the beginning, we also have the Mitsubishi. So you see if we click on Mitsubishi, we have different possibilities. You see they call it LD, LDI. So it's a bit different. Their timers is a bit different also. Okay, so we try to support as many as possible. The Siemens PLC, it's still based on our basic interface like we had before. We will eventually have the Siemens the same way we have the Allen Bradley and Mitsubishi, which will be much more close to the real Siemens programming tool and same functions. But it's work in progress. But we still have access to all the timers and counters and converters, comparators in the Siemens like you would find. It's just that we need to update this library as we updated the other one as well. Okay? So let me show you a sample in which we use a PLC like this, use the Siemens model, just to give you an idea of what we can do. So let me just come here, demo 7. We have one called Siemens here with middle bender. So like I say, it's used mainly to practice students to learn how to connect all kinds of different PLC. So when they go out for a job, they'll know that if the PLC is different, just look at the technical data, just learn how to power, energize the inputs and outputs, and just create your circuit. So you see here, for example, let's zoom out. So this is our Siemens PLC. So we need to know that we need to jump our command like that to all the different sections. And if I zoom all again, and I start simulation, I hit start, I can actually see my PLC getting triggered inputs and outputs to control the schematic on the left, according to this program. Okay, so this is what the PLC are interesting because students can actually really wire this up and actually write the program also inside. Okay, so here's another circuit sample to show you a bit the more advanced feature of the PLC ladder logic. Here we're actually using a sequencer. So as you can see here on my sequencer, I can configure the address of the mask as well as defining all my structure of the sequencer. If I go here in the ladder diagram, I open the PLC configurator. You see here is actually my sequencer. And I can see that my step 1, these are the bits I'm turning on, then step 2, step 3, step 4, and this is my mask here defining which of the bits I will take. The here is pretty easy right now, we're just taking like the 6th last bit. So this is the one that will be modified. And this is something that we can review more in detail, like I was telling you, on a more advanced PLC demonstration with our colleagues. So when I start the simulation, you see here, we actually have our circuit. I can turn this on. And now I can just push one time start. And we can see that the outputs are actually controlled receiving from my sequencer, which actually sends the output to B32, which is the output on my PLC. If I zoom in here, you see this is my MicroLogic 1400, and being able to display a bit bigger the actual screen here of the PLC to see the inputs and outputs energizing. So if I say that I keep it always on, I can see my sequence here being controlled by my sequencer. And again, this is what I'm telling you, when we can schedule a more advanced PLC with one of our colleagues who will know about a lot more in this field, that can explain you how we can easily configure those sequencers and work from there. So this is what I wanted to show you for the PLC part, AB-500, AB-5000. Now we're going to complete the circuit, the multi-technology circuit that we started a couple weeks ago. Okay. So this is the part one that we've done 2 weeks ago. We built the pneumatic here. Last week we focused on the electrical part with the illustrated PLC for the compact logic. And now we're going to focus on building the control part to animate the entire system here. Okay, so let's go back to Automation Studio. Okay, so now let's open the file that we started, the multi-technology project, so the part 3. You will see on the project that we're opening now, if you did not participate to the past webinars, this is the pneumatic part. We have the electrical we've done, the contactors, overload, motors. We've also inserted an illustrated view of the compact logic. If you already work with that PLC, you'll notice that we've decided to, instead of use the inputs and outputs connectors, which were here, it was pretty condensed. So we actually created cards like that on each side, which we just put jumpers like this. So it offers us in Automation Studio to have more flexibility to connect different components to the inputs and outputs. Also, we've actually created a mechanical link. So this electrical motor is actually controlling the compressor on the motor on my compressor here. Okay, so they're both linked together. Okay, so this is something that we can do with the software as well. So let me just zoom window so we can maximize this. And like we said before, we're going to be controlling this using the Studio 5000. So we need to create a new document ladder diagram, which will be AB-5000. Okay, so I can just shrink this window so it goes, let's say, in this spot right now. And I can go in my library and simply just drag a rung, let's say the power rail. Okay, and let's just start working on that schematic now. So let's just come here in the ladder diagram and just click on PLC configurator. We want to add variables, so I'm just going to move it around here so I know what I'm looking for. So let's add. So now these are all the variables. But you see the one for my PLC are all the logical one, column I, data 1, data 0. So those are kind of like the by default registered in the data table of the PLC. Okay, so I'm going to need, let me just zoom in here. Oh, sorry, I'm just going to have to zoom in first here on my in and my out. So I'm going to need, so let's go, this is logical, I think, local. So I'm going to search by local. There you go. And I can sort that by order like that. Okay, so I'm going to need my input 0, 2, 4, and 6. So 0, 2, 4, and 6. Okay, so these are my inputs. Then in my output, I'm going to need my 0, 1, and 2. So output here, 0, 1, and 2. Again, you see there are still inputs, so I just need to make sure they're outputs. And now I can actually give them the tag names that I want. So let's use the tag that I've used on my electrical circuit here. So my input 0 is actually my start. So let's come here and call this start. If I want, I can put a description here as well, like we did before. Now I'm going to, my input 2, it's my stop. So let's click here and call this stop. Input 4 is actually my PS1. The 6 is PS2. The output 0 is Sol1. Output 1 is Sol2. And my output 2 is actually the coil of my contactor, so it's C1. C1. I could have named it motor start, but let's just name it C1. So now I can close this, and I'm now ready to put the logic here that will control the circuit. Okay, so when I push start, I want first the motor to start. So I need to close C1 here, energize C1. So I'm going to come here. So I'm going to take XIC. Okay, so this is going to be linked to my start. Okay, something that you need to know, okay, in Automation Studio, when you try to put a component on a window that is not the right type of document, there's a message that pop up with an error in it, okay? So you see so now, because I'm always going over an electrical diagram, you're always going to see the same error at the bottom, okay? But no, because I'm not dropping it here, it doesn't matter. It's just that it senses that it's going over something that it should not. That's why it's giving me a warning. Okay, you'll see when I bring this, you'll see what's going to happen. You see the error shows up, but it doesn't matter. I can drop it here without any problem. Okay, so now I look for C1. So now this, when I hit start, I'm going to start my C1. Energize output C1. That's going to latch here and actually start my motor because it's going to close the contactor. So I just need to latch this. So I can just hit the control key, bring this one back down, click twice on it, and go and click twice on C1. And this is going to be latched here. So now that it's done, I'm going to start, let's say, if I'm in position PS1, I want to actually activate Sol1. So I have a condition of C1 being true, and also PS1. So I'm going to copy this here, click twice, and then go PS1. When C1 and PS1 are true, then I'm going to energize my Sol1. So again, I can just copy and paste this here, click twice, and go Sol1. So you see the editing is pretty quick, with the cut and paste like that, it's very fast. So now I will energize C1. And then let's say when I reach the PS2, I want to count before it's retracting. Okay, so I'm going to say, okay, let's go down here. So next time the PS2 is on my input 6. I don't really need to know because it's tag name based. So I'm just going to come here, link that to my PS2, associate that like this, and that will start a timer. So it looks a bit like we did before, but a bit different. So the message, it's this, by the way, is going to be changed, okay? In a future release, when you're going to go over a certain type of document, it will not pop up, okay? I could have just took this window. I'll show you what I could have done. Okay, let's just put that delay. Cylinder A, cylinder. A, for example. Okay, so when that's done, I approve. Oh, sorry, it's not here. I need to add it. It's not already existing. So there it is. And my preset, let's put 3000 millisecond again. Okay, what I'm saying is that I could have just brought this window like this here while I'm building the logic so the pop-up doesn't show up. Okay, but I just want to make it look simple for you guys, so I'm going to leave it here and just disregard the message that pop-ups every time. Okay, so when the timer is reached, I'm going to need to energize Sol 2. Okay, because basically this is it's not spring return, so I don't need to latch it or keep it. I'm just gonna go and energize Sol 2. So the done bit here, so let's put an open contact like that. This will be the done bit of my timer. So I come here and I choose the done bit like this. So delay cylinder A, the done bit of that, will actually energize my Sol 2. So let's copy Sol 1 down here. Click twice, Sol 2. And then I'm going to go like this. So you see, again, like we saw before, if I right click here and I go ladder and I go for the 5000 here, I can decide what to display and how to highlight it. Okay, so you see, I can put the description and things like that. I can highlight the color of the background of the description. So I could have entered more information if I wanted to, like I showed you at the beginning. Okay, so this is something that you can always configure. So now I'm doing this, and then when I hit stop, I want it to stop. Basically, the stop button that's over here. So let's just take a normally close, and I'm going to link it to stop. So let me just put this a bit like that. I just need more space for my PLC. So here's the program. So now I'm just going to save that as part 3. No, you know what? I'm going to call it part 3 final. And let's start it and see if it works. Let's finish with save. Okay, so now if I launch the simulation, okay, my input 4 here is energized because my PS1 is down. I can see here the light open on my sensor, and then I can see that it's closed over here, which energizes my input 4. So now if I click on the start, you see the motor starts. My cylinder is energized, but it's not moving because this is closed here, so I'm not letting the air go into the system. So if I click here, air goes in. Let me zoom out here. So there you go. So we have our system that after 3 seconds retract, then goes back up. So we can see here on the PLC my inputs and outputs getting triggered to control the circuit. On this circuit here, I can actually take measurements also. So I can go here and take measurement of the current on the motor. And if I hit stop, it finishes the cycle. The motor is de-energized. Everything stops. So let's do it again. So let's get rid of the multimeter clamp. Let's just start that. And there you go. So we have a multi-technology circuit that we created, and all using mainly the illustrated libraries that we have in Automation Studio. Note that I could have done the exact same thing using symbols. But we've been doing symbols with Automation Studio for the last 20 years, So this is something new. That's why I wanted to create that using the more realistic illustrated component to work with. These illustrated components, we can create pretty much any kind of libraries that's needed. We had a presentation this morning, and we had somebody who says, you know what, I'm teaching aviation maintenance. Can I get picked images like that looks like the real component in a plane? So when my students wire up the components, they're actually feeling like they're working on the plane itself with the real components. I said, no problem. We just need you to supply us with like an image, the description, the technical specification, so we can reproduce a circuit for you to be able to create illustrated views of your schematic for students so they can better understand. And it really helps to transition again from theory to practice by seeing the entire system work like this. So this is pretty much what I wanted to show you today. We completed the illustrated multi-technology project that we talked about. In the next webinar, we will actually insert faults in the circuit. So we'll show you how to put fault on different components and also how to protect a document so students cannot modify the schematic or cannot even have access to the properties of the components, because when you do troubleshooting, you don't want the students to know that you've put a leak inside a cylinder, for example, or that you put a normally open contact where it should be closed and things like that. So in the next week's video, we will actually show you how to put these faults. So now that we've finished this circuit, I first want to thank you for being here. And now we've reached the end of the presentation where we are open to any questions that you may have. So please feel free to raise your hand on your interface of GoToMeeting. It's a small N. If you click on it, I'll see it. And I'll be able to give you the mic so you can ask your question live. Or if you don't want to say it live, you can just write your question in the question interface at the bottom, and we'll be able to read that and answer your question for everyone's they can understand, and I'm sure your questions will be questions of others as well. So please don't hesitate. And then thanks again for being here. We hope to see you in the next webinar, and we will be sending you an email with the links of the video that we've done so far. So we've sent you the link for the video on the hydraulics, pneumatics, the electrical part, and the PLC that we did, because they are all required to build a multi-technology project that we did today. So thanks again for your time, and now we're open to your questions. Thank you.